let's find the derivative of the arcsin function. Okay? So for instance, here down below here I've given you the derivative of the arc cosine function. What is it? It's this function right here. How do you use it? Just like you've used any other derivative. Okay? Incorporate it into things you know. We'll get some more practice with it next time. But what I'm actually interested in is deriving these derivative formulas. And I will ask you on your next exam to derive one of them. Here's what we're going to do. We're going to write y is equal to the arcsine of x. And you actually saw this technique in some of the earlier sections. I think in 3.8 we did this technique. It wasn't 3.8, it was 3.9. We did this. I don't know how to take the derivative of this inverse function. But I do know how to take the derivative of its inverse, right? I don't know how to take the derivative of arcsine, but I do know how to take the derivative of sine. So let's rewrite this as a sine expression. Okay? So let's just double check, make sure everything aligns. I'm taking the arcsine right now of a ratio, and it's returning an angle. So then I'll take the sine, that's equivalent to saying that the sine of the angle is equal to this ratio, provided I'm within that restricted domain and range. Now I'll implicitly differentiate both sides. So let me take the derivative of both sides with respect to x. The derivative of the sine of an expression is the cosine of that expression times the derivative of that expression by the chain rule. Okay. That's equal to what over here? 1. Because there we're taking dx dx. So there's no chain rule. Okay. So, well, who are we trying to find? We're trying to find dy dx. Well, there it is. Let's get it by itself. So we get dy dx is equal to 1 over the cosine of y. Folks, I highly recommend you look at the way our author derives these, because the author gets to here and does something different from me. He uses the I don't know, there's several of them, use the Pythagorean theorem. Okay? Using some of your Pythagorean your Pythagorean identities from trigonometry. And I think that their derivation is more careful than mine. Mine's a little sloppy. People could poke holes in it. The reason why I'm showing it to you is because I think that this technique is really, really useful come Calc 2. In Calc 2, you're going to be doing a bunch of trig substitutions. The technique is called. And they are tough. And I think if you can do this little technique, it's very helpful. At this point, I get stuck. I've got a trig expression, and I'm stuck. When I get stuck, I draw myself a triangle. Okay? So let's do that. Let's draw a triangle. Here's our triangle. Okay? Now, let's label things correctly. What is the angle on this right triangle? Well, it's got a 90-degree in it. What angle are we dealing with here? We're going to give it a name. What's its name? It's y. So there's the angle y. When I take the sine of y, what type of object does it return? It returns a ratio. What's a ratio? It's a fancy word for a fraction, right? Okay. Well, here's our x. Is that a fraction? What did they teach you in algebra? Algebra 1, when they want you to think of that as a fraction, what did they say? Think of it as being over 1. There, now it's a fraction. What fraction specifically is it for our triangle? It's the ratio of the opposite over the hypotenuse. So what goes here? 1. And what goes here? X. What am I trying to do? I'm trying to find the cosine of this angle. I don't know what the angle is. How do I find its cosine? I don't actually have to find the angle to know the cosine of this angle, right? Because I can find this side right here. What's this missing side? From the Pythagorean theorem, it would be the square root of 1 minus x squared. Everyone see how I did that? Can you talk about it? So then that gives me that dy dx is equal to 1 over, what is the cosine of this triangle I just drew? The cosine is the adjacent over the hypotenuse, right? So it's 1 over, so there's the 1 over, and then let me give the cosine of this triangle. Well, that's not, do it like this. What is the cosine of this triangle? It is the square root of 1 minus x squared all over 1, right? But at long last, what have we said? We said if we want to take the derivative of the arcsine of x, what is its derivative? We've said that it's 1 over the square root of 1 minus x squared.